All right, good morning, you guys. Today we're taking on a sphere, a beautiful sphere. Okay, so first up, how do we define it? The set of all points that are equidistant, so same distance, equidistant, from a fixed point, which is our center. So the set of all points that are equidistant from a fixed point, which is our center. So here is our center, and if I connect from the center to any point all the way around in every direction, that's our radius. So equidistant just means that same distance is the radius. Okay, so surface area, I took some pictures. I might show you a link to a little video. Without trying to overcomplicate things, we typically show you just a video with an orange, where you can see that if we cut a cross section of an orange, which represents our sphere, right, here's my example for a sphere here, and I peel away the skin of the orange, I should be able to fill 4 cross sections of my sphere with the peel of the orange, which is the collective surface area. So for surface area, we think of it as just 4 cross sections, 4 circles, 4 pi r squared. So here, let me write that formula, and it's really the same as saying 4 cross sections of the sphere. Okay, volume. So volume, here, let me just write the formula first, and then I'm going to explain it. So volume ends up being 4/3 pi r cubed. So a good way to picture it is here is the very center of my sphere. And I'm trying to picture as many pyramids as I can with their vertex at the center and their bases on the sphere surface. So I've drawn in 2, but I want you to imagine more and more and more filling up that inside space of the sphere. So I can picture it as, wow, I have a lot of pyramids that are filling up that space. So I can visualize that as my volume is like my first pyramid. Plus, I have a second pyramid all the way until I get to the very last pyramid to fill up that space. So I'm just making sure we see that we just have different bases. So base 1, base 2, base n, for example, for the last pyramid that would fill up my sphere. So then I need to think, okay, well, the height of each pyramid is actually, picture the height, right? So if I connect here, center of the sphere to center of the pyramid, well, that height is really a radius. So I can do a little swap in variable and think, okay, well, my height is really the radius. So let's first just reconsolidate, take all of these terms, divide out the 1/3 and the height, which we know is actually the radius. I'm just going to save that thought for a moment. And then I'm going to divide out from each of these terms the 1/3 and the height. So then I have all of their collective bases all adding up inside of my parentheses. Okay, and remember what we already decided. We decided that the height of the pyramid is really the radius of my sphere. So I'm going to swap out here that height with an r. And I know that all of their collective bases make up the total surface area of my sphere. So I can plug in here 4 pi r squared. So now I have my volume is 1/3 times the radius times 4 pi r squared. So when I multiply that straight across, I get my 4/3, I get my pi, and I have an r times an r to the 2nd power. There's my r to the 3rd power. So my formula for volume is 4/3 pi r cubed. All right, slide it up. So find the surface area and volume of a sphere with a radius of 12 inches. Okay. So surface area is 4 pi r squared. Volume is 4/3 pi r cubed. So all I'm doing is plugging in a 12 for the radius. So I have 4 times 144 pi, so 576 pi square inches. Okay, over here I have for volume 4/3 times 12 cubed, so 1,728, and then pi, so that will multiply out to be 2,304 pi square, or not square, cubic inches. Volume is always units cubed. All right, next example. Here, my diameter is 30 inches. So if that's my diameter, my radius has to be half of it. So my radius would be 15 inches. So then again, if I lay out my formula, surface area is 4 pi r squared. Volume is 4/3 pi r cubed. Why don't you pause, plug in that radius of 15, and then unpause to see if we match. We should end up with 900 pi square inches for surface area and 4,500 pi cubic inches for volume. All right, next up, the radius is x over 6. That's the same as writing that as 1/6 of x. So I want to make sure you see that clearly. X over 6 is the same as 1/6 of x. Okay, so surface area, let's lay out the formula. So 4 pi r squared, and volume is 4/3 pi r cubed. So we're just plugging in that x over 6 or 1/6 x into our radius. So here I have 4 pi, and then I have x over 6 squared. So really that's saying 4 pi times x squared over 36. Okay, I can reduce because I can put that 4 pi over 1, visualize it as a fraction, and that 4 and 36 can reduce to 1 and 9. So I'm going to end up with, I'll put the x squared over 9 first, and then the pi last. Okay, if you put the pi along with the numerator, that's perfectly fine also. And this would just be square feet. Okay, I could also write this as 1/9 x squared pi square feet, and that would be perfectly fine. It just means the same thing. Okay, volume, I'm plugging in the x over 6 here as well. So I have 4/3 pi, and then x over 6 to the 3rd power. So now I have 4/3 pi times x to the 3rd over 216. So again, I can reduce further. I can see that the 4 and the 216, they're both divisible by 4, so I can reduce this to a 1 here and a 54 right here. So then I could write this as 1 over 162, that's just 3 times 54, and then x to the 3rd power, and then the pi, and then feet cubed. All right, diameter is 8x. So here again, we know that the radius would be half of it. Radius would be 4x feet. Okay, so if I plug in here my surface area, I know it's 4 pi r squared. So 4 pi times 4x as a quantity being squared. So really, I have 4 pi times 16x squared. So 4 times 16 is 64, and then x squared pi square feet. Okay, for volume, volume is 4/3 pi r cubed. So I'm plugging in the 4x here. So 4/3 pi times 4x cubed. So 4/3 pi times 64, x to the third power, just like that. So here, if I multiply 4 times 64 and then divide it by 3, I'm going to get 85 1/3. I'm just writing that as a mixed fraction. And then x to the third, and then the pi, and my feet are cubed. So area is always square units, and volume is always units cubed. All right, example 2. Find the surface area of the sphere based on the area of a cross-section through its center. So we're given the cross-section. So our formula, surface area is 4 times A. That A is a cross-section. So all I have to do right here is plug in a 16, and I get 64 square feet. Okay, over here, I know that, well, surface area is going to be 4 cross-sections. So 4 times 36 pi will get me 144 pi square feet. So again, this really goes back to the orange video, and I'll show you some pictures as well, because I did practice this last night, just using my compass, making the 4 cross sections and peeling an orange. So here we know that our surface area, that is 4 pi r squared, is the same as just 4 cross sections of a sphere. All right, let's flip. Let's do that second page. Okay, so here I'm saying find surface area and volume of each composite solid. So here we're looking at 2 or more figures that are connected. So for this one in A, right here it looks like I have an ice cream cone, right, where I have my cone like this, and then I have a semi-sphere, a half sphere, stacked on top of it. Okay, so if I'm looking at my surface area, I need to make a game plan. So let's do it down here. So surface area, how am I going to get there? Well, what's exposed? For the cone, it's just the lateral area of the cone, and then really half of the surface area for my sphere, a semi-sphere, a half sphere. So I'm going to need the lateral area of the cone, and then I need to add a hemisphere, a half sphere. Okay, I can already see that I'm going to need my slant height right here, so let me take a moment and solve for it using Pythagorean theorem. So I know that 4 squared plus 10 squared equals the slant height squared. So 16 plus 100 equals the slant height squared. Slant height squared equals 116. Take the square root of each side. 116 is going to be 4 times 29. So I'm going to get plus or minus 2 root 29. But of course, I'm only interested in the positive. I cannot have a negative measurement. So my slant height is 2 root 29. Okay, so now I'm going to have all the parts that I need. So my lateral area of the cone is the pi r slant height. For my sphere, I'm taking half of 4 pi r squared. So my radius of the cone is 4. The slant height of the cone is 2 root 29. Okay, my sphere, the radius is 4. So if I multiply out right here, I'm going to get 8 times pi times the square root of 29. And then over here, I'm taking half of 4 pi r squared. So really 2 pi r squared. So 2 times 16 pi will get me 32 pi. Right? They're not like terms. I can't combine them. So I leave it as is, unit squared. Okay, and then I need volume. Okay, volume is usually easier than surface area for the composite solids. So here I really just need my cone, and I need, again, a hemisphere. I need half of a sphere. So I'm looking at cone plus half of a sphere. So my cone, I'm looking at 1/3 pi r squared times the height, and then half of a sphere, half of 4/3 pi r cubed. Okay, so my radius is 4. The height of my cone is 10. The radius of my sphere is 4. So when I multiply this out, 1/2 times 16 times 10, I get 53 1/3 pi. Here I'm taking 4/3 of 64 and then multiplying that by 1/2. So I get 42 2/3 pi. Okay, these are like terms. I can combine them and get to 96 pi units cubed. All right, moving over to B. So for B, I'm looking at, it looks like a trophy. So I'm looking at my surface area, and then I'm looking at my volume. So if I picture it starting with the sphere, I have this whole sphere, but I'd have to take out this little circular part of the cylinder where they're connected. For the cylinder, I really just need my lateral area, right? I picture a soup can. I just need the label of it. And then I have here a rectangular prism, but again, I have to remove that circle that's connected right here. Okay, that one that is marked, that looks like that's the full diameter. So let me make a note of that up top, that my diameter is 1 inch right there for the cylinder. So the base of the cylinder has a diameter of 1 inch, which means that the radius would be half. So radius would be half. Okay, I'd like you to pause for a moment and see if you can write out that plan, right? I just went through it. I want to see if you can write out your master plan for getting to the surface area of my trophy. Okay, and then when you're ready, I'm just going to write it all out one more time. Okay, so unpause when you're ready, and here we go. So surface area in total. We start with the sphere. Find the total surface area of the sphere. Let's take out that circle that was the top of the cylinder. So minus 1 circle. I'm just going to write it like that. And then I have to add back in just the lateral area of the cylinder. Okay, and then I need to add it to the prism. But I need to take away that circle down here as well, because that part right there is not an exposed surface of the prism. So I need to take away a second circle. Okay, so I have my master plan. Now I'm going to write out my formulas. So for my sphere, that's 4 pi r squared. The circle, pi r squared. The lateral area of the cylinder, that's the circumference times its height, so 2 pi r h. The prism is going to be the height of the prism times the perimeter of its base, plus the 2 base areas, but then I have to take out that circle, pi r squared. All right, so I have it all laid out in terms of the formula. And then I'm going to plug in for the radius of the circle. I'm sorry, not radius of the circle, radius of the sphere. Radius of the sphere here must be 2.5. Okay, of the circle right here, the radius would be 0.5. Okay, radius of the cylinder, 0.5. Height of the cylinder is 6. Height of the prism here is 2. Perimeter of its base looks like it must be a square, so 5, 5, 5, and 5 makes 20. A base area, 5 times 5 makes 25. And then this circle again right here, the radius is 0.5. All right, so when I multiply this out here, I'm going to get 25 pi. Here, 0.5 squared, so 0.25 pi. 2 times 0.5 times 6 is 6 pi. Okay, height times perimeter, so 40. 2 base areas, 50. Okay, other circle right here, 0.25 pi. All right, so everything that has a pi can combine. So let me just underline all of those like terms. So 25 minus 0.25 plus 6 minus 0.25 will get me 30.5 pi. And then 40 plus 50 is 90, okay, square inches. All right, we got to the surface area. That was a challenging one for sure. Okay, volume is always easier. So volume, I just have to take my, my sphere, add it to my cylinder, add it to my prism. So sphere plus the cylinder plus the prism. So my sphere is 4/3 pi r cubed. My cylinder, pi r squared times the height. And my prism base area times the height. So here I'm plugging in for the sphere a radius of 2.5, for the cylinder a radius of 0.5 and a height of 6, and for the prism a base area of 25 and a height of 2. So I'm going to get 20 and 5/6 pi. Here I'm going to get 1.5 pi. And then plus 50. So if I combine here and here, I'm going to get 22 and 1/3 pi plus 50, and then inches cubed. Okay, a couple more examples. Example 4. So the sphere fits snugly inside of a cube with 6-inch edges. Find the volume of the space between the sphere and the cube. Okay, well that's pretty easy, right? That's just saying your volume will be find the cube, but remove the sphere. So the cube, we know that that's a side cubed, and sphere, we know that that is 4/3 pi r cubed. So my radius of the sphere, right, it looks like a diameter is 6, so radius would have to be 3. For the cube, all of the sides have to be 6. But again, the radius of the sphere would have to be 3. So cube, I'm going to plug in a 6 here, and sphere, I'm plugging in a 3 here. So 6 cubed is 216 minus 4/3 of 27. 3 cubed is 27, gets me 36, and then pi. So my answer would be 216 minus 36 pi cubic inches. All right, lastly, find the volume of a sphere when our surface area is 324 pi inches squared. Okay, so we know surface area, we want volume. So surface area we know is 4 pi r squared. And we're given that it's 324 pi. We want volume. Volume is 4/3 pi r cubed. Okay, so we got to find the radius, right? The radius is our key to getting to our volume. So we know that 4 pi r squared equals 324 pi. Okay, and then I divide away the 4 pi, and I get the radius squared is 81. Take the square root of each side. R would be plus or minus 9, but we know it's only the positive 9. So my radius has to be 9, so that's then what I'm plugging in over here. So 4/3 times 9 to the 3rd power will get me 972 pi inches cubed. All right, one last problem. Find the surface area of the sphere when we know the volume. So here we know that volume is 4/3 pi r cubed, and we're given volume as 288 pi. Okay, we want surface area 4 pi r squared. So I need to figure out my radius. So again, it's my radius that's my connector. So I can set 4/3 pi r cubed equal to 288 pi. Okay, I'd probably clear my fraction by multiplying each side just by 3/4. I'm just going to make that go to 1 really fast, just like that. So I have pi r cubed is equal to, well, 288 times 3/4 is 216 pi. Okay, I want to get the pi out by dividing each side by pi. So now my radius cubed equals 216, and now I can solve by taking the cube root of each side, and I get that my radius is 6. So I plug in a 6 over here. So 4 times 6 squared, 4 times 36, and I get 144 pi inches squared. All right, so at this point, we've learned about all of our solids, right? We started with our cube, our prism, our cylinder, our pyramid, our cone, and our sphere. So we have covered them all at this point. All right, that's all I got for today. Have a wonderful rest of your day.